I'm going to review this Kaiweets Smart Digital Multimeter. This is the KM601. I'm going to do some interesting stuff for this review. I'm not going to do like everybody else does, but I'm going to do that too. But I'm also going to do some precision testing, something nobody else seems to do. I mean, I have calibrators, I have reference capacitors, I have all kinds of little bits and pieces we can try on this and check the accuracy. So if you want to find out how accurate this thing is, make sure you stick around. Defpom approved. Also, don't forget to click like and subscribe, especially if it's your first time here. Now, this is given to me for free by Kaiweets directly. They sent it to me, so I haven't paid for this. This is, you know, a gift to me for the review. But I still tell it how it is, and I don't skew my opinion based on the fact I've got something for free. So first, we look at the manual. I tend to not read manuals, but what we will look at though is the specifications. You can probably hear the fan noise in the background. That's my Datron Calibrator warming up. It's a bit noisy. Max input between terminals is 1000 volts DC, 750 AC, which is actually surprising. I would have thought it would be less than that for a budget meter, but we're going to try it. We're going to see if it goes bang or not. I can generate these voltages on my calibrator. We're going to try it. Accuracy specs, this is something which we may refer back to later on. I'm not sure if I'm going to do actual comparisons with the specs. I'm just going to show you what it actually does rather than comparing the specs. I don't know yet. It's got 5 ranges on DC volts. It also has auto ranging and stuff like that on it. We'll look at that. It's got a 4-digit resolution. So it says plus or minus 0.5%, which is pretty good. Plus 3 counts. AC is the same ranges basically, except the top range is now 750 volts. And it's got a rated specification for the frequency of 40 Hz to 1 kHz with true IMS. So we shall see how this turns out. I can generate all these frequencies across my calibrator there. We'll just try some frequencies and compare it against the spec maybe for this one and see how it actually measures. Can we exceed the spec? Don't know, we'll find out. AC and DC current. But my calibrator can do up to 2 amps. Capacitance. Now, this is a range most people cannot check accurately. They might check some capacitors off the shelf, and I may even do that for some bigger values. But so I do have some standard capacitors sitting right here. So we can actually hook those up and do some true known capacitances. Now the biggest standard capacitor I've got is 1 microfarad. I can only do decent testing onto 1 microfarad, so it's basically these first 4 ranges I can test. These ones I will have to use a substitute, off-the-shelf capacitor and do a comparative test. One thing that isn't specified here is what frequency this tests at. I've actually got notes on my standard caps here. So I've got 100 Hz and 10 kHz, for example, here, and it shows what this one gave, to give you an idea of what the range is like in those caps. I've also got diode test as well, we'll see how that goes, and continuity buzzer, which is below 50 ohms apparently. So that's alright, we might check that for how quick it is. And also you've got standard resistance ranges, which is supposed to be plus or minus 1%, plus 5 counts, up to 100 mega ohms, it's got 100 mega ohm range. Frequency and duty response as well, and duty cycle, which will be 1% to 99%. It's got 1% rating, so actually the ratings on the accuracy is not bad really for the price of point this meter. This meter's not expensive, it's pretty cheap really. And also got temperature readings. Now I can kind of test temperature. I'm not really set up for that. I'm not really going to focus on this too much. The biggest influence on temperature accuracy is the thermocouple you've got, so it's kind of subjective. So that's quite a long intro, wasn't it? God, it's ages to read those specs. Came with 6 batteries. It takes 3, so it actually gives you enough batteries to run it for a while. I don't know what the battery life is like actually. So here's the meter. So it's a nice hard case, or semi-hard case. It's pretty rigid, so it's gives it some good protection. And also got the original lead to come with it. So actually look at these original leads. You've got a thermocouple. We'll look at that too, maybe. We'll look at the original leads, see what they're like. Generally on cheaper meters, the leads aren't super high quality, but they're usually adequate for the job. These are PVC leads, not silicon. That's not unsurprising. One thing with leads is the better the quality of the lead, the more responsive it is to things like the continuity testing. I've got these little covers over these things. 1000 volt Cat 2. It's got a Cat 3 rating with the clips on these covers. There's a Cat 2 rating without the covers at 1000 volts and 600 volt. Cat 4, as it says in the manual. I mean, these leads are kind of okay. Depends what you want, but generally I like better leads. Got these nice ones here. These are some Pomona leads. These look pretty good. They sent me these for free a little while ago as a review item, and these are really nice leads. They've actually got like a built-in shield. You can just spin it and you get the shield come out. These are really nice. So if you've got this meter and you want some better leads for it, maybe you should look at these Pomona ones. These are pretty good. You get what you pay for. In my case, I didn't pay anything, so yeah. Does that still apply? I don't know. Let's turn this thing on. It's got this rubberized case, which I peeled off already. It's a PVC case, which is plasticized polyvinyl chloride, for those that don't know about plastics. At least that's what it feels like to me. And this peels off, and then you can take the back cover off. Now behind here there's a single screw. We'll have a look at this later on, we'll do the teardown, but a single screw there which is on a threaded insert, and then you've got the batteries sit just in here. It has a torch which I think only powers up when it's got it turned on, so let's power it up. There's a display, and it defaults into auto mode. Now the angles on this are quite interesting. I actually mentioned this in the mailbag. The display is optimised for actually being facing away from you slightly like that, so it's tipped down, so it's as if they've actually allowed for the fact that when you're using this meter it's going to be on your bench like this flat, and you're looking upwards at it, which means they've considered that aspect and actually arranged the display so that the angle of viewing is actually the optimal angle, so you can get the best brightness off the display. Auto ranging, you can see it actually just switches range to range to range. It's going between volts, ohms and continuity, right? So it's automatically jumping continuously, it's just cycling through them. And let's do manual moding, let's do that one there. So it does seem to have some residue on here. Let's give that a wipe. Having clean probes is quite important for getting decent readings. So these are obviously just nickel probes. So to me that is actually a bit slow. I mean, it will do it, but a bit slow. Okay, if I change these probes to different ones, it might be slightly faster. Let me try that. So these are the Pomona probes. Right, these are high quality probes. Now to it. Right. That's much faster. Probe quality makes a surprising difference. It's because of the contact resistance of the actual coating on the probe tip. So that's a consideration. I mean, I might be able to get them clean and get them better. So there was some residue there. So it's, I'll do the same thing I was doing with the other probe. Nowhere near as good. Probes are important. So I just gave these tips a bit of a clean up with some alcohol, and now it's a bit better. It's definitely improved. Maybe they'll get better with time anyway. So first we'll go through and look at the actual system on the screen, what functions it has on it, and then we'll do some testing of actual accuracy and see what it can actually produce. So this is auto mode, we'll say it shows between voltage, AC and DC voltage, resistance and the continuity buzzer. So if you do push it first, it goes to voltage, and it says DC here. Lighting's drowning out a little bit for the view, but it actually looks better in person than it does on camera. It doesn't really do its service. So let's push range. What does that do? So the manual range is now shown up over here. So it's volt range. Select. There we go. Let's do select. So now we've got AC instead. Right. It's also got a frequency readout here, so you can see the frequency that the AC circle was running at. And it'll be the same ranges. So push function again. Resistance. Manual ranging. We've got min, max, and relative and hold. If you want to take a reading with this. It's also showing temperature here. So 22 degrees is measuring. Let's probe those together. There we go. Short, relative, or hold. There we go. It's hold. So how do I do relative? But min, max, max resistance, min resistance. If I touch them together, they should then lock onto what I got, and that's working fine. Turn it back off again. So we've got continuity buzz. I've already played with that. Diode test. That should basically show like that. That's fine. I've got this board sitting over here. Let's see what I can find. Here we go. There's a diode right there. So like that. There we go. 0.7 volts. That's fine. And that around 0.42. Because it's in circuit, you only get weird readings. That's the way it is. Capacitance. So let's actually test the capacitor, shall we? Let's just shove the probes in here. This is a bit dirty actually, this capacitor, but I'll figure out how to do relative on this thing. So that's zero those leads out. So hold relative down with them just open like this. That should at least make sure there's nothing there. We'll stick the probes in here. Now long leads isn't great for capacitance, which is 182 picofarad. Now this capacitor is supposedly 198. Let's try another capacitor. This one here is the next one up. This is a 1 nanofarad. Stick the leads in here again. This one's looking better. Again, we don't know what the frequency is of this thing right now. So the frequency could be affecting this reading. In fact, it likely is. And as I've got this range marked on here, I'm guessing this might be a 1 kHz reference then, because 1 kHz is reading lower than that, and 10 kHz is reading higher than that. So it could be a 1 kilohertz. Quite possibly anyway. Let's try one more. This one is a 20 nanofarad and that's reading high. Now my monitor's on here actually reading lower than that. I'll do a comparison with DER as well soon. We'll go and check that out. This one's 1 microfarad and this is reading a bit low. So this is a 1 microfarad exactly at 100 Hz and 1.005 microfarad at 10 kilohertz. So it's below both of those. So now I've got some Pomona clip leads instead, right, nice and short. Now something this does have is a bar graph on the bottom here which seems to respond quite quickly. Let's just go to resistance. So that does respond fairly quickly. I need a variable resistance to see that one really. We'll see what we get from that 1 microfarad again. It's pretty much the same as we got with the test leads 991s. It's reading a bit low. So we need to find out what frequency this thing's running on, just out of curiosity. So I've just got my BM786 here. I'm just going to probe onto this. It's not going to be super accurate, but it's going to be good enough to give us an idea what's going on. 5.7 Hertz. If I take one of the clip leads off, now we're getting 3.6 kilohertz. My estimate of about 1 kilohertz test frequency was probably not far off. So if I hook this up to something else, and we'll probe this one again as well. This is the 200 picofarad capacitor. Now you get 3.1 kilohertz. So obviously that frequency is going to change with the capacitance. And with these clip leads on here, you're getting 164 picofarads on that meter there. Don't forget to click like and subscribe if you enjoyed the video so far. So testing that same capacitor with the DER 5000. Look what we're getting. That's on 1 kilohertz. That's exactly 200 picofarad. And if I change frequencies, so we're getting 200 picofarads on this range, 100 Hertz, on 20 Hertz we're getting 199, basically getting 200 right across. Right, 1 kilohertz is pretty much there, 10 kilohertz pretty much there, 100 kilohertz 198 basically. So this is reading much higher than this, so I believe this meter, I think the capacitance is off on this one a little bit on that low range. And that's measuring 20.26. So let's remeasure this one with the DER and see what that thinks of it. And that's what the DER thinks of it, exactly 20 nanofarad at 1 kilohertz. Let's change frequencies. So 10 kilohertz, 100 kilohertz, 100 hertz. So now measuring a 1000 microfarad 63 volt electrolytic capacitor. It's a bit of a step up from the 1 microfarad test capacitor right over here. So it's measuring 977 or so. I've got the DER set up at 100 hertz, which you can just about see there. Which we'll swap over. Let's see what this one thinks of the same capacitor. So this is actually really a little bit lower. On the bigger caps it seems to be slightly better than the small caps by the looks of it. Let's try higher frequency, let's try 1 kilohertz. That's reading 900. I imagine this frequency is going to drop down quite a bit with that big capacitor on there. Let's measure a 100 microfarad 160 volt, which is quite a big chunky one. Let's see how it handles that. $101, that's actually looking pretty good. Let's see what this one thinks of it. This is still at 1 kilohertz, 97. So, like I said, I normally do use 100 hertz for these big caps. So 100 hertz, getting 99. Which one's right? Who knows? I've got my other tester up here. We'll test it with this. It says 99.2 at 100 hertz. So this was closer. So I think we've done capacitance to death now. Let's look at the next thing. So we've got voltages here, low voltages. We'll do that on the calibrator. We'll skip that one. We've got frequency here as well. Could potentially generate a signal for that. I might leave that one. It's duty cycles usually, you know, it's there or it's not. It's pretty simple, not usually an issue. Temperature again, we won't look at that too closely. I can plug a thermocouple in, I suppose. We'll look at that. So the thermocouple is plugged in, and we've got a dual display here, 72 Fahrenheit or 22 degrees C. I don't know. Let's touch the thermocouple. What happens? It goes up. So a dual display is nice. It's quite handy. Don't have to do conversion. Is it accurate? Don't know. I don't really do thermocouple testing, so can't tell you for true. But again, it depends on your thermocouple. If you've got a decent thermocouple, you'll be accurate. If you've got a bad, cheap quality one, maybe it won't be. Next function is non-contact voltage. So I need to find something that's got power going to it. That works. So I've just got this cable here which has got 240 volts on it. There you go. But just then when I did that test, I was actually doing it on the wire for my lights, which is set a shot. But that's just a wire going to my light. That's low voltage, and it detected that. That's quite interesting. So the next thing we got here is milliamps. It's warning about lead connections, and it's got these LEDs flashing just here. Well, they stopped flashing now, but they were flashing to say about the lead. So I want to plug into those two connections there. If I go to amps, it's flashing these two instead. That tells you which leads to plug in, which is good for a newbie, I suppose, and also gives you a bit of a visual prompt to make sure you don't mess it up, because we've never done that, and it does the same thing here as well. It flashes on those ones for voltage range. So let's go over to where the calibrator is and actually do some calibration checks. So here we are over the calibrator. So here's my Datron 4700 calibrator. Here's my Datron 1082 7.5 digit multimeter. So we've got 4 more digits on here than we've got on here. Bit of accuracy available. I'm injecting 1 volt right now. You can see I'm doing parallel measurements, so this is measuring the voltage as well. So this is the actual voltage coming out of the calibrator, and this is what this meter is reading at 1 volt. Accuracy's kind of okay. It's alright, it's in a few counts. So let's do some more challenging tests. Let's do 10 volts, about 6 counts down there. Let's do 100 volts here. So 100 volts, we're doing 99.8 on there. These are still warming up, so not perfectly stable, so you know the last digit on here is not right. These have only been on for, I don't know, maybe an hour. They're not really warmed up yet, but it's way in excess of what this needs to do the testing anyway, so I'm not worried about that part. So this is saying it's 200 millivolts out compared to this at 100 volts. So let's go a bit higher. Go down and say 500 first as a starting point. And that overloaded. It didn't like this thing trying to find the ranging. So this has got quite good sensitivity for the output loading. So it detects a short in the output or something like that, it will actually dump it. So which is what happened, it tripped out. 500 volts exactly coming out. We have 0.6 volts low. Not too bad. It's alright, I suppose. What's that in percentages? Like 1% out. It's 0.1% out. That seems okay, actually. I mean, don't forget what I'm comparing against to is quite expensive test equipment. This thing here was worth about 10 grand. Alright, so, yeah. This is a couple of grand. Well, I don't know, probably about 3 grand, I think, for one of these. Yeah, this is somewhat cheaper. So that's 500 volts. That's fine. Let's go a bit higher. Let's do 800. So it's looking slightly better there. Look at that. 900. That's bang on. So maybe it's calibrated right at the top of the scale, and so the midpoint is a bit out. So 1000 volts. Over range. Okay, let's go down to 1 volt. There we go. That's 200 millivolts high there. So it looks like the calibration point is probably 900 volts, because that's the one which is accurate. So let's bring it back down to 200 volts. 4 counts out. So let's go back down to a lower voltage. Let's do 20 volts. 7 volts is kind of there. 5 volts. Do the voltage that people care about. Yeah, it's 3 counts out. It's alright. Half a volt. This is where this thing does the auto range flicking around. The half a volt seems to be the threshold for it. So we go to manual ranging, and there we go, it's reading 1 millivolt down. Yeah, so what? Let's go lower. Actually, let's go down to millivolt range over here. Right, let's bring this around. Millivolts. That's reading much more accurately there. It's only 3 counts out, that's pretty good. So let's go down to 50 millivolts. That's pretty good. 1 count out. 5 millivolts. Bang on, that's good. 0.5 millivolts. Yep, that seems fine. 0.49, 1 count out. Oh, jumped up a little bit. Maybe its resolution is a bit jumpy there. Maybe its ADC doesn't have quite enough resolution to do 1 count at that level. Looks like it's jumping by 2 counts. Okay, let's go a bit lower. 50 microvolts. And yep, that's reading it. That's looking alright. Now this is actually quite interesting. So I've now switched over to doing AC volts. So I'm doing 1 kHz AC, which is supposed to be the maximum frequency of this thing. And I'm doing half a millivolt, so it's 500 microvolts, and it's actually measuring basically right. Now my Datron over here isn't liking this in this particular case. 1 kHz is measuring right. So let's go down to 100 Hz. Still measures right. So let's go down lower. 50 Hz, still measuring fine. 40, 20 Hz, still there. 10 Hz, it's starting to drop off a bit there. So it's 2 kHz, it's still reading it. 10 kHz, I can't read that. So it's like 2 kHz is actually like the top end at this low level there. So let's go up the ranges a bit. So 5 millivolts. I got the ranges and I'll come back down again. I've changed the frequency. So 50 millivolts. Yep. 500 millivolts. It's a few counts down here, but don't forget I'm at 2 kilohertz, not 1 kilohertz, which is what the top's supposed to be. So 5 volts. Because I'm in a millivolt range, I need to drop this around. And AC. So there we go. 5 volts. AC is definitely sitting a bit off there. So I think the frequency here needs to come down. So there we go. That's where it's affecting it there. So we go through the rest of the way. So 50 volts AC. That's looking alright. 500 volts AC. 501 at 1 kilohertz. Let's couple it up a bit more. It's a little bit out there. So let's go up to 750. And it's beeping, so it's overloading. 740, there we go. So it does have protection built in. Get back down to 1 volt. And full range there. So 1 volt AC. That's there, 1 kilohertz. So let's change the frequency. 100 hertz AC, which is quite a common frequency you want to measure at. That's basically bang on at 1 volt. So 100 millivolts. 10 millivolts, that's actually bang on. So now let's test current. So I've got it set on the amps range right now, just a precautionary key in case I mess it up. And we're doing 100 milliamps DC amps, and we're reading 97, so it's out by a few counts. Let's do 10 milliamps, although this isn't really meant for this range, should really use in the other range. And that's reading quite low. It's a few counts out still. So it really should be on the other range of milliamps anyway. So let's go up to 1 amp, and we are getting close to 1 amp, 5 counts down there. I can't go much higher, I can only do 2 amps on this thing. So 1.9 amp, so there is no higher range on this. Can't do it. Wish I had a 10 amp range, it'd be perfect then, but unfortunately not. It's to AC. So let's go down there, full scale that. Go to AC amps, change this to AC. So there we go. So 100 milliamps AC in the 1 amp range, well in the 10 amp range, is basically doing 99 milliamps. That's pretty good at 1 kilohertz. Let's go 1 amp. It's also measuring the frequency there exactly, 1 kilohertz. So that's also bang on current as well. It's perfect. So let's change frequency. Let's do 100 hertz. See how that handles that. Frequency's bang on. Current is a few counts down again, but that's not too bad. Let's go to 2 kilohertz. And that's still reading fine. Still got the frequency there as well. 3 kilohertz. Current accuracy is dropping. Frequency is still there though. It's rearranging. 4 kilohertz is there. Obviously the current is completely way off now. Oh, push on button. 5, yep. Let's go down in frequency. Let's do 30 hertz. Reading kind of okay. 20. Frequency is still looking good. 10. It's dropping off, and it's having trouble locking onto it now as well. It's not quite sure, it's aliasing slightly. It's a bit too slow for it, so it was supposed to be 40 hertz, don't forget, at the bottom end, so we're already doing better than that. So I discovered this really nice feature. I was wondering why I couldn't change ranges, because it's sensing on the jack. It knows that I've got that connector in that jack. When I unplugged it, then I was able to change modes. So that's actually pretty clever. So I have it over here on diode. I plug in the current. It's jumped back in the current straight away. So if I plug that into the milliamp one, it's jumped in the milliamp. So it's sensing those plugs automatically and changing automatically, which is great. That's really nice. That's a really good feature. Well, it doesn't do it for voltage because there's no harm doing that, but the amount of times people have had the leads in the current range and then tried to measure a voltage with it. So that's really good. It's actually forcing you to use the correct mode, so it's really good. That's a really good feature. I like that. Someone was thinking. Right, so let's measure the milliamp range here on AC. I'm still on the AC settings on here. So we'll turn the output on to 100 milliamps and still at 20 hertz, and it's measuring 20 hertz fine, and it's really 98. So yes, it can go below that 40 hertz spec. So I put on 40 hertz and that's much more accurate there. So we'll bring it up to 1 kilohertz, and there we go. Bang on. Perfect. So 2 kilohertz, still good. So it actually exceeds the spec. 3 kilohertz, now the current is dropping off, but it's still at a radio frequency. 10 milliamps. Bang on. Perfect. 300 microamps is like the limit of where that frequency can be read, so that's an interesting thing to know. But yeah, it works right down to 10 microamps, that's fine. You know, it can read it. Alright, just no frequency readout. But it can read the current. That's on AC. We'll change over to DC and flick this over to DC. So current DC, we'll turn it on, and we're getting, so 7 microamps there. Let's go 100 microamps. 98. So 1 milliamp. That's not too bad, it's a couple of counts out. 100 milliamps. I need to make sure I don't go to the next range because I'll pop the fuse. So 10 milliamps, that's doing okay. Let's bring this up. 50, yep. Let's do 100. That's looking alright too. It's looking pretty accurate. Let's do resistance. Right, let's measure resistance. I'm using my Fluke 5450A here, dedicated resistance calibrator. Got it set up on resistance already, got the leads plugged in. Let's do a short. It's looking fairly good there, a few counts. What we might do is do a relative measurement against that to zero it. So that's now zeroed. In 2-wire mode, this would have originally had test leads which were calibrated with the unit, and those were set up on here to tell you what the resistance of those leads was. I don't have those leads. This you can pretty much ignore on these really low resistances in 2-wire mode. I might just use 4-wire mode actually and just leave the display like that. 0, let's go up by 1. So this is 1 ohm, and as you can see it's not actually getting there. Don't forget we did do the relative changing there, which did drop it down by a bit, so maybe turn the relative back off. So with that relative it's actually looking pretty close. It's bang on 1 ohm basically. So if we ignore the relative mode for zeroing, it's right. Okay, so 10 ohms, reading 0.4 high, so 100 ohms, just under 1%, which is within spec. 1% spec, don't forget, plus a few counts. So 1k, it's within 1 count, that's pretty good. 10k, again within 1 count. Oh, no, it's flicking on 10k, so it's actually pretty good there. 100k, bang on. Let's do 1 meg, and that's flicking between ranges. Manual ranging. So there's the top end of the 1 meg range, or the bottom end of the 10 meg range, whichever one you want to use I suppose, up to 10 meg, so 9.9999, and yep, that's basically there. So let's go up to 100 meg. Can you read it? You can. That's actually surprisingly good. I'm actually genuinely surprised. So let's go down a range. So we've got 19 meg there, 19, so 1.9, yep, so 190k, look at that, basically bang on. 19, 190 ohms, 19, 1.9, that's where it's getting a bit out down the bottom end here, and that's the zeroing. It's actually not bad. Don't forget to click like and subscribe. So in my opinion, this little meter here is actually pretty good. I'm pleasantly surprised. Accuracy is everything it said it was in the manual. In fact, it exceeded it. It worked well. So I'm showing you this torch on the back here, have I? APO as well. So automatic power off, I'll show you about those. APO means it's got automatic power off, or you can disable it. So by doing that, it now won't turn off automatically, so it means it will stay on until you turn it off, or until your batteries go flat, whichever one comes first. So that's a handy feature, you can just quickly turn it on off as you need it. Very nice. And also got the torch button here, so it's got an LED torch on the back. So if you're trying to work on something and need to see a bit more about what you're doing, it is doing something. If you're in a dark area, yeah, it's kind of alright. It's not wonderful, but you know, it could be handy, maybe. Should I do a teardown? Nah, maybe I won't do a teardown. Other people have done teardowns on their videos, so if you want to see one of these things torn apart, go and look at one of the other people's videos, because there's not really much to see. You've got some fuses down the sides here. There's not really much to it. This video is already long enough. Plenty long enough. I've been recording for about 2 hours now. That's a lot of editing to do. So thank you very much, Kaiweets, for sending this to me at no cost. I'm pleasantly surprised. This is a good little meter. If you're getting into electronics and you want something which looks reasonably accurate and has good features and does things to try and avoid you blowing up your meter or stuff like that by having the sensing on the leads and forcing you to use the mode by depending which lead you got plugged in, that's very good. They've got some really good features on this thing. I'm actually impressed, especially for the price. So make sure you go and check out the links down below for this in the description there to Kaiweets and consider buying one. I mean, this is a nice little meter. I might put this in my car. I don't know what battery life is like. It is electronic switching, so there will be some level of battery draining with it turned off. I don't know what that level actually is. Defpom approved. So yeah, don't forget to click like and subscribe, and I'll catch you in the next video. Might be repairing my 5450A with a slightly dirty relay again. Bye.